Imagine standing on a quiet beach at sunrise, when suddenly a creature longer than a car washes up at your feet. Its silver body glimmers like metal, its eyes dark and unblinking, as if it has risen from a world not meant to be seen by humans. This isn't a scene from a sci-fi movie that has happened repeatedly across Japan, California, Indonesia, and Chile. Oarfish appearing in shallow waters, giant squids floating near fishing boats, deep-sea sharks caught just meters from the surface. But why? Why are animals that normally live thousands of meters below, in crushing darkness and freezing pressure, suddenly emerging into our world? Some people whisper that these creatures rise before disasters. Others say the ocean is warning us, and some believe the deep sea is beginning to unlock, revealing species scientists have never studied alive. But the truth may be even stranger, because behind every unusual sighting is a chain reaction: warming oceans, shifting currents, underwater tremors, collapsing food webs, and human activities that reach deeper than we ever imagined. What exactly is forcing deep-sea life to break the surface? And is this just the beginning? Let's dive into the hidden story the ocean is trying to tell. For years, researchers thought that the deep ocean was one of the rare areas on Earth unaffected by human impact, an ancient, quiet realm enclosed under immense pressure. However, over the last 10 years, an exceptional occurrence has taken place. Beings that ought to stay deep beneath the surface are ascending into shallow waters, moving towards shores, and showing up in areas where they shouldn't exist. This enigma isn't merely strange, it's significant. Animals in the deep sea are among the most responsive indicators of shifts on our Earth. If they are leaving the darkness and entering our world, it signifies that something in the ocean, our planet's biggest life support system, is changing. These changes can uncover early signs of ecosystem failure, natural calamities, climate alterations, and the effects of human actions deep below the sunlight's reach. On this channel, we refuse to accept just headlines or basic explanations. We reveal the narrative behind the science and the genuine factors lying beneath the surface. Today, we're exploring more thoroughly than any news segment ever could. To comprehend why these beings are emerging, we must first grasp what the deep ocean truly is and how delicate it has turned. What lives in the deep sea? When we mention the deep sea, we're not merely speaking of deep water, we're referring to the biggest and least examined habitat on the planet. The deep ocean starts at about 200 meters, where light diminishes into constant twilight. Beyond 1,000 meters is the midnight zone, an area so dark that not a single beam of light can reach it. At depths of 4,000 meters and beyond, we enter the Abyssal Zone, where pressure reaches an unfathomable level, more than 400 times that at the surface. Venture further down into depths such as the Mariana Trench, where conditions are so severe that they challenge the survival of life. Still, within this frigid, high-pressure gloom, life flourishes. Creatures of the deep ocean have developed remarkable adaptations for survival. Certain species, such as the deep-sea anglerfish, employ glowing lures produced by bioluminescent bacteria to draw in prey in complete darkness. The colossal squid, a mythical creature seldom spotted alive, traverses the abyss with eyes as big as dinner plates, uniquely designed to sense dim light or movement from threats such as sperm whales. The oarfish, Earth's longest bony fish, swims through the abyss like a shimmering ribbon, living at depths where temperatures approach freezing. Different beings appear almost extraterrestrial. Siphonophores, akin to jellyfish, can extend longer than blue whales, creating fragile drifting colonies that emit glowing bioluminescent pulses. Bristleworms, some exhibiting clear bodies while others boast shimmering metallic hues, traverse hydrothermal vents or float through dark waters with peculiar frilled limbs. To withstand intense pressure, numerous deep-sea creatures possess adaptable bodies, reduced air cavities, and unique proteins that stop their cells from collapsing. Their metabolic rates are remarkably low, enabling them to live on minimal food. Some depend on marine snow, a constant drift of dead organisms and organic particles falling from above. Others gather around volcanic vents, feeding off chemicals instead of sunlight. But because they are so finely tuned for life in this extreme world, deep-sea creatures almost never come near the surface. Up here, the pressure is too low, the temperature too warm, the light too bright. Their bodies are designed to function under tons of weight. Without that pressure, some can suffer internal damage, disorientation, or immediate death. Many cannot navigate or hunt in the bright, chaotic waters near the surface. This is why every sighting of a deep-sea animal at shallow depths is not only rare, it's a sign that something in their hidden world has changed. Recent global sightings. In the last 10 years, sightings of deep-sea organisms at the surface have increased significantly, and these occurrences are not unique. They are occurring around the world, in various climates and seas, creating a trend that researchers can no longer overlook. In 2013, Japan caught attention as several oarfish, with some exceeding 5 meters in length, appeared on the shores within a few weeks. Residents linked the observations to forthcoming earthquakes, intensifying anxiety and superstition. Researchers argued that the connection wasn't established, yet they conceded the timing was odd. By 2015, fishermen along the coasts of Chile and Peru started catching deep-dwelling squid and lanternfish in nets designed for surface fish. Videos shared online depicted fishermen astonished as glowing bioluminescent beings flailed on the deck, creatures typically residing hundreds of meters below. Marine biologists there noted that warm water anomalies were pushing species out of their natural zones. In 2017, a viral video from Indonesia captured villagers surrounding a massive decomposing creature initially labeled a sea monster that turned out to be a deep-sea baleen whale that had risen unnaturally fast. The size of the carcass, the crimson water surrounding it, and the disarray among residents generated worldwide attention. In 2020, a live deep-sea goblin shark was captured close to Australia's shoreline, well above its usual depth. Researchers described the sighting as rare and troubling, highlighting that these sharks typically do not come near surface waters unless they are disoriented or in distress. In the past few years, from 2021 to 2024, social media has seen an influx of videos featuring glowing siphonophores alongside kayaking tourists, anglerfish arriving on California shores, and giant squids observed near fishing boats in the North Atlantic. Every video accumulates millions of views, evoking a blend of wonder and fear as individuals encounter animals they never anticipated witnessing beyond documentaries. Researchers globally have reacted with a mix of intrigue and wariness. One marine ecologist remarked, "These observations are important data points, but when deep-sea species come to the surface, it usually indicates that the deeper environment is experiencing stress." Some cautioned that the ocean could be experiencing rapid changes that we don't yet completely comprehend. To the general public, these occurrences frequently resemble narratives of mythical sea creatures emerging from concealed realms. For researchers, they serve as indicators in a broader developing narrative regarding the evolving condition of our oceans. In any case, one fact is obvious: the deep ocean is beginning to approach us. What people think versus reality. Whenever a deep-sea creature surfaces, the internet lights up with dramatic theories. Certain individuals consider these creatures to be harbingers of natural calamities, particularly in regions such as Japan, where encounters with oarfish are frequently associated with impending earthquakes. Videos become popular with titles such as "Sea Creature Forecasts the Next Major Earthquake," and the notion circulates more quickly than the actual scientific evidence. Some envision these beings as hostile intruders, emerging from the depths to assault shores or alert humanity about a dire event. Some even assert that deep-sea species are escaping from enormous underwater beings, colossal predators driving them to the surface. Yet, in spite of the intrigue and apprehension, the scientific truth is much more tangible. There is no verified evidence that oarfish or any deep-sea species can foresee earthquakes, while underwater seismic activity can disturb deep environments, causing disorientation or forcing animals from their habitats. This isn't a supernatural warning system, it's simple environmental stress. Creatures from the deep sea aren't assaulting coastlines either. In reality, many are extremely delicate. When they arrive in shallow waters, it's typically due to an issue: elevated temperatures, reduced oxygen levels, contamination, injury, or being diverted by powerful currents. In reality, these creatures are neither harbingers of disaster nor beasts emerging from old legends. They're indicators, living sensors of the ocean's health. When they appear at the surface, they're unintentionally revealing that something in their world is changing, and often it's a change caused by us. The real causes. Now that we've explored the sightings and myths, it's time to uncover the real reasons deep-sea creatures are rising. These causes are scientific, interconnected, and far more alarming than folklore. Climate change and warming oceans. If there is one element strong enough to transform the deep sea, it's increasing global temperatures. Though many consider climate change primarily related to weather, ice caps, or coral reefs, the reality is much broader. The deep ocean is also warming, and even a slight rise in temperature can thrust its vulnerable species into turmoil. The deep ocean is generally steady, chilly, heavy, and sluggish. For countless years, temperatures in deep layers have remained near the freezing point. However, in recent decades, researchers have noted temperature anomalies gradually descending through the water column like a slowly advancing shadow. Warm water not only warms the surface, it circulates, descends, and alters the ocean's structure. A significant change occurs in the thermocline, the layer that divides warm surface waters from the colder depths. Consider it a barrier or thermal barrier. However, climate change is deteriorating this barrier. As surface waters warm, the thermocline becomes unstable, permitting warm water to penetrate deeper than before, and once it occurs, deep-sea ecosystems adapted to stable cold conditions are disrupted. Numerous species adapted to thrive at particular temperatures. Their metabolism, buoyancy, and survival hinge on this. As the deep layer heats up, these creatures naturally seek out cooler water, but down in the abyss, there's nowhere deeper to go, so instead, they move upward. This vertical movement is a main reason why deep-sea species find themselves in locations they were never intended to inhabit. Envision a massive squid ascending steadily, not searching for prey or adventure, but urgently pursuing the frigid temperatures essential for its survival. Or an oarfish rising to the surface as the temperature at its normal depth has turned uncomfortably hot. Rising ocean temperatures also disturb the deep food web, beginning with the tiniest life forms. Plankton. Small planktonic organisms create the foundation of the ocean's complete food network, and they are highly responsive to temperature changes. When temperatures shift, plankton move, die, or reproduce differently. This affects the entire cascade of life, including deep-sea creatures that rely on marine snow, the falling organic material that drifts down from surface ecosystems. If plankton populations crash or shift position, deep-sea animals may rise to search for food that is no longer reaching their depths. This hunger-driven migration is especially dangerous because these animals are not built for shallower pressure or brighter environments. Ocean heat waves, massive, long-lasting patches of warm water are becoming more common too. These underwater heat spikes can travel downward, forcing entire communities of deep-dwelling species toward cooler layers near the surface. Fishermen frequently observe unusual catches during these times, with deep-sea species showing up in nets intended for surface fish. Climate change is not only heating the Earth, it's altering the structure of the ocean. Layers are blending, food is transitioning, and species are relocating vertically in unprecedented ways. And for deep-sea creatures built for stability, this vertical escape often brings them straight into our world, weak, disoriented, and far from home. Oxygen minimum zones expanding. Concealed deep beneath the surface, certain areas of the ocean have oxygen concentrations that decline to such an extent that most organisms can scarcely endure. These areas are referred to as oxygen minimum zones, or OMZs, and they are emerging as one of the most concerning changes occurring in the deep ocean. To grasp OMZs, think of ocean layers piled up like the levels in a skyscraper. Close to the surface, sunlight drives photosynthesis, producing oxygen-filled waters. However, as you go deeper to mid-level depths ranging from approximately 200 to 1,000 meters, oxygen levels naturally decrease. This layer has always been present, but it used to be quite narrow and stable. Currently, due to rising ocean temperatures and escalating pollution levels, these low oxygen areas are spreading, becoming broader, deeper, and more oppressive. When oxygen decreases in an environment, marine organisms have three options: adjust, escape, or perish. This is the reason it's occurring. Warmer oceans retain less oxygen, and climate change is increasing temperatures in the seas from the surface downward. At the same time, Nutrient runoff from farms and wastewater leads to significant plankton blooms at the surface. As these plankton perish and descend, bacteria decompose them in a process that uses large quantities of oxygen. Combined, these two forces form deadly pockets, where oxygen levels drop to nearly zero. For deep-sea creatures accustomed to stable, cold, oxygen-poor environments, this should be normal, but the scale of today's OMZ expansion is unprecedented. As oxygen dwindles in their mid-depth habitats, these species must move either higher or lower. However, deeper waters might be excessively cold or pressurized, limiting the choice to one viable option: ascend toward the surface to find breathable water. Researchers examining expanding OMZs near the coasts of California, Chile, Peru, and certain regions of the Indian Ocean have recorded deep-sea species emerging much closer to the surface than anticipated. Lanternfish, squid, deep-sea shrimp, and even certain species of sharks have been recorded swimming well above their typical zones during low-oxygen events. Fishermen often report catching these creatures in nets designed for surface species, a clear sign they're fleeing an oxygen crisis below. In some areas, OMZs have grown so large that they create oxygen cliffs, sharp boundaries where oxygen levels drop off rapidly. As these cliffs rise, they compress habitable zones, squeezing deep-sea organisms into thinner layers of survivable water. This crowding forces unusual upward migrations and increases the chances of deep creatures appearing at the surface, disoriented and stressed. The expansion of oxygen minimum zones is essentially choking life from below, pushing species upward into environments they're not designed to handle. And as OMZs continue to grow, we're likely to see even more deep-sea creatures rise into unfamiliar waters, revealing the dramatic changes unfolding in the ocean's hidden depths. Underwater earthquakes, volcanic activity, and seismic disturbances. Far beneath the ocean's surface, tremendous geological activities are continuously in motion. Tectonic plates move, submerged volcanoes release warmth into the ocean, and unexpected earthquakes generate vibrations within the water column. Although these occurrences frequently escape the attention of surface dwellers, they can significantly disturb deep-sea ecosystems and occasionally drive animals to rise. During an underwater earthquake, the ocean floor can shift dramatically, unleashing waves of energy that ascend like underwater thunder. These shockwaves disturb sediments, dislocate water layers, and change the chemical equilibrium in nearby regions. For creatures residing thousands of meters below, where consistency is crucial, even a minor disruption can seem like their entire world has been disrupted. Certain fish might surface prior to a disturbance, since deep-sea creatures are highly responsive to low-frequency vibrations and variations in water pressure. They are capable of identifying slight changes far earlier than land-based instruments. Others rise after the event, fleeing disturbed seafloor zones where toxic chemicals, heat, or debris suddenly appear. However, it's important to separate science from folklore. Despite popular belief, especially surrounding oarfish sightings, there is no confirmed scientific evidence that deep-sea creatures can predict earthquakes. What is true is that underwater seismic activity can create stressful or inhospitable conditions, indirectly causing species to move into higher waters. This relationship is more apparent in areas with significant seismic activity. Along the Pacific Ring of Fire, known for frequent earthquakes and volcanic activity, there has been a rise in unusual deep-sea observations in recent years. Researchers have recorded increases in deep fish and squid populations off the coasts of Japan, Chile, and Indonesia immediately following significant underwater earthquakes. Eruptions from hydrothermal vents have been associated with abrupt migrations as heated, mineral-laden water inundates nearby ecosystems. In truth, these creatures are not harbingers of disaster. They are casualties of a disturbed ecosystem. When the seafloor moves, their habitats change instantly, and sometimes the only escape is upward, into waters where they struggle to survive. Seismic disturbances may not summon deep-sea creatures, but they certainly can displace them, pulling ancient life briefly into our world whenever the Earth shifts beneath the waves. Human activities, shipping, mining, sonar, drilling. The deep ocean might appear isolated, but human actions are extending further than before, leading to significant impacts on deep-sea organisms. One of the most immediate effects arises from deep-sea mining. Businesses are examining the seabed for valuable metals such as cobalt, nickel, and rare earth elements. The operation utilizes large machinery to drill into sediments, creating shockwaves in the water that can extend for hundreds of meters. These vibrations can confuse deep-sea animals, driving them upward into strange, shallower regions. Military sonar represents another crucial element. Strong low-frequency sonar pulses are employed to identify submarines, yet these sound waves propagate long distances beneath the surface and disrupt the navigation systems of marine creatures. Deep-sea species such as squids, sharks, and some fish depend on sensing pressure and movement for hunting and migration. Powerful sonar can disorient them, leading to stress, unpredictable behavior, or even abrupt upward movement. Overfishing creates an additional level of stress. By eliminating numerous predatory species at different depths, humans are unintentionally pushing others to migrate in search of food. Starved or displaced deep-sea fish might swim nearer to the surface in search of adequate food. Ultimately, noise pollution underwater from shipping routes, drilling platforms, and industrial operations is increasing consistently. The steady drone and vibrations alter animal behavior, stress their metabolism, and interfere with communication. Numerous deep-sea organisms are very responsive to sound, utilizing it for foraging, reproduction, or evading threats. When their auditory surroundings become intolerable, the only choice is frequently to shift, occasionally into surface waters they are unprepared to navigate. Collectively, these human-caused disruptions are a significant, frequently ignored force, propelling deep-sea organisms into our realm. In contrast to natural migrations, these upward movements are driven by stress, perilous, and unsustainable for the animals affected. Pollution and chemical changes. Even the most remote areas of the ocean are now affected by human pollution. Plastic and microplastics, previously believed to remain at the surface, have been discovered in the Mariana Trench and various other deep-sea trenches. These minuscule particles are consumed by filter feeders and scavengers, including deep-sea shrimp, lanternfish, and brittle stars, obstructing digestive tracts and diminishing nutrient absorption. Eventually, this may diminish populations and compel certain species to migrate to shallower areas in pursuit of cleaner feeding locations. Ocean acidification poses a quiet yet lethal danger. With increasing levels of carbon dioxide in the atmosphere, the ocean takes in additional CO, creating carbonic acid and decreasing pH levels. Acidic waters disrupt the capacity of deep-sea creatures to create shells and skeletal frameworks, especially impacting crustaceans and mollusks. When their survival is threatened, the fish and squid predators are compelled to seek food in other areas, occasionally nearer to the surface. Human waste dumping near trenches, including chemical runoff and industrial waste, has created localized hotspots of contamination even in extreme depths. Heavy metals, oils, and harmful substances accumulate on the ocean floor, contaminating environments that organisms have inhabited for centuries. Animals compelled to vacate these contaminated regions frequently move into strange, shallow areas where survival is precarious. The interplay of plastics, chemical contaminants, and acidification poses a cumulative strain on deep-sea ecosystems. These alterations are nuanced, frequently unnoticed, yet deeply disruptive. When beings emerge close to the surface, it's seldom a simple migration. It's an alarm from some of the most isolated and delicate life forms on Earth. Humanity's impact has literally reached the bottom of the ocean, pushing life out of its ancient homes and into a world it wasn't built to survive. Case studies. Case Study 1. In 2013, Japan witnessed an unusual increase in oarfish sightings near coastal regions. Numerous residents thought the lengthy silver sea serpents were signaling forthcoming earthquakes, a legend based in centuries of tradition. Researchers, however, proposed a blend of seismic events and ecological pressure. Underwater disturbances might have affected their environments, while increasing ocean temperatures and changes in oxygen levels probably compelled the fish to migrate upward. The conclusion: these unusual occurrences were a reaction to ecological disturbance, rather than a mystical foretelling. Case Study 2. Fishermen along the coasts of Chile and Peru recorded sightings of giant squid and lanternfish in shallower waters from 2015 to 2017. Studies showed that marine heat waves and El Niño occurrences changed ocean stratification, leading to temperature anomalies and disturbing the typical thermocline. Deep-sea species were pushed toward the surface, frequently ensnared in nets meant for shallow water fish. Researchers highlighted that these movements were reactions to shifting thermal conditions instead of being arbitrary occurrences. Case Study 3. In the 2014-2015 blob marine heatwave along California's coast, scientists noted strange sightings of deep-sea anglerfish, bristleworms and siphonophores in the upper water layers. The heatwave led to changes in oxygen minimum zones and food supply, compelling species to move upward for survival. Researchers determined that climate-related stressors were directly accountable for these observations, offering immediate proof of deep-sea ecosystems reacting to environmental alterations. What does this mean for the future? The increasing sightings of deep-sea organisms are not merely oddities, they serve as early indicators of the condition of our oceans. As climate change raises ocean temperatures, enlarges oxygen-poor areas, and disturbs food webs, we can anticipate more regular and widespread appearances of deep-sea organisms close to the surface. Beings that were previously concealed in the deep, such as enormous squids, deep-sea sharks, or glowing siphonophores, might frequently appear in shallower waters, providing researchers a unique glimpse into existence in extreme depths. The effects on the ecosystem could be significant. As deep-sea organisms ascend, they could vie with surface inhabitants for nourishment, changing current food webs. Displaced predators and their prey can initiate cascading effects within the marine ecosystem, potentially destabilizing fisheries and endangering species that people depend on for food. For coastal communities, these changes are both remarkable and worrisome. Fishermen might discover strange, delicate organisms in their nets, as tourism and local environments can be impacted by unexpected arrivals of deep-sea species. Crucially, the emergence of deep-sea species indicates greater environmental stressors, such as rising temperatures, pollution, and habitat degradation that might eventually affect human health, fishing industries, and worldwide food stability. The deep ocean has always been a realm of enigma, a domain of perpetual darkness, immense pressure, and beings that appear almost extraterrestrial. For thousands of years, existence flourished there undetected, adapting to rhythms and circumstances that humans could hardly conceive. However, that concealed world is emerging into ours. Oarfish washed ashore, colossal squids close to fishing vessels, luminous siphonophores floating in coastal waters. These are not mere coincidences. They indicate transformation, tension, and upheaval in the ocean's farthest ecosystems. Science indicates that climate change, oxygen loss, seismic activity, pollution, and human actions are driving these organisms to move upward, frequently into habitats where survival is not guaranteed. However, in their looks, there exists an unusual beauty, a view into ecosystems that were formerly entirely inaccessible, a reminder of the intricacy and vulnerability of existence below the surface. While we admire these uncommon guests, we should also consider, if the deep sea is surfacing, what other messages from our oceans are we overlooking? Each emerging being serves as a signal and a call to comprehend, safeguard, and honor the oceans before the secrets they contain turn into alerts that arrive too late to recognize.